Welcome to my channel, students. It is Quest Edu Physics. Today we are going to learn about the collisions. Okay, students. First of all, we have to understand what is the collision is. What is the collision? Generally, we think collision is what the colliding in between the two bodies. Here, if you watch it carefully, physically the two bodies are coming and they are hitting with each other. Maybe. But you have to remember one thing. In collision, there is no need of physical contact between the two bodies. There is no need of. Maybe there is a physical contact, but it is not needed. Always the bodies have to come in physical contact. I think you are understanding. If one body comes under the influence of the other body, if one body comes under the influence of other body, it is also known as the collision. Or simply we can define the collision like this. It is a mutual interaction between the two bodies. Collision is the mutual interaction between the two bodies. Here, interaction is either it is the attraction or repulsion. I mean, if one body comes under the influence of the other body, we can call it as the collision. We can come across with different cases in collisions. Here, if you take an atom, okay, at the center of the atom, the positive charge is located. Everyone knows that. And electrons are revolving around the nucleus. We know. There is a mutual interaction which is happening between the electrons and as well as the protons. It is the collision. One body comes under the influence of another body. Okay, students, in the same way, try to bring two similar poles of magnets. We know that they repel with each other. They move away from each other. It is also the collision. In the same way, if you bring the dissimilar poles, what happens? They attract. Okay, they come in contact with each other. It is also the collision. Okay, students. Actually, these collisions are classified into two types, students. One is elastic collision and second is inelastic. One is the elastic collision and second is the inelastic collision. First of all, we have to understand what is the elastic collision. A collision in which both kinetic energy and momentum of the body. Okay, students, both the kinetic energy and the momentum of the body is conserved. If the kinetic energy and as well as the momentum, here kinetic energy and momentum, we show the momentum with P, isn't it? Okay, both kinetic energy and momentum are conserved. What is the meaning of conserved? They remains constant after the collision, before the collision, in the process of the collision. Both kinetic energy and momentum are constant. We call it as the elastic collision. Okay, students. Elastic collision. Okay. Elastic collision means what? Both the kinetic energy and momentum remains constant. That means you can say, simply we can understand is very easily. Let's say it's a ball which is moving with a certain velocity and along its path one more ball is moving with another velocity. Okay, think this ball has more velocity compared to this. Obviously, they collide with each other. Temporarily, what happened? They come in contact with each other. Okay, then they get separated. Here you can say, when they come in contact with each other, maybe they lost their shape. Okay, this one lost its shape. Okay, it cannot be seen with our naked eye, but you can feel it. It lost its shape. After the collision, they get separated. They came back to the same state. That means what? They regain their same state. Such collision is known as elastic collision. As you know that elasticity is nothing but, what is that? Regaining the original state after the removal of the deforming force. Means what? External force. After the removal of the deforming force, the body comes back to its original state. We call it as the property of elasticity. Here the same thing is happening. Temporarily it lost its shape. Then after, what did happen? It came back to the original states. Such thing is known as elastic. That's why I told you, in elastic collision, kinetic energy and momentum remains constant. You know that kinetic energy is equal to half mv square and momentum is pv. Both should be constant. Just think, does it possible? Yes, I told you. If you take the collision between the fundamental particles, we can say it is the elastic collision. Okay, students? In the same way, the collision between two ivory balls is somewhat near to the perfectly elastic collision. The collision between two ivory balls. You know that ivory is the tooth of the elephant. It has the greatest elastic properties. That's why if you watch the squash, that means billiards. If you watch the billiards board, you will find so many colored balls, isn't it? And they have to be hit by the cue. Okay, students, cue means what? That rod, the wooden stick. Then the collision which is happening between the two ivory balls is nearly perfect elastic collision. In the same way, the collision of the ping pong balls, that means when you play the table tennis, those ping pong balls are, what's that? The best example for the near perfectly elastic collision, or you can say elastic collision. I hope you understood what is the elastic collision is. It is the collision in which both the kinetic energy and momentum of the body remains constant. Before the collision and after the collision, these two physical quantities remains constant. And the second one, inelastic or non-elastic. Inelastic. What is the inelastic? Okay. Here it is a simple answer, students. A collision in which only the momentum is conserved. Okay, students, only the momentum is conserved. Such kind of collision is known as inelastic collision. That means what? The kinetic energy of the body is changing. I mean, kinetic energy is not constant. K is not conserved. It's not constant. Okay. And we come across with so many inelastic collisions in our daily life. Maybe it's a collision, it is inelastic. Here maybe you heard some song, Okay, sound is released. Okay, when we hit a ball with a bat, it's a cricket season, isn't it, students? When a ball is being hit by bat, what could happen? We will hear a sweet sound. It is the example for inelastic collision. How can you recognize it? A simple way. Only momentum is concerned. The kinetic energy may appear in the form of light and as well as the sound, and also in the form of the heat. After the collision, there appears to be somewhat heated. I mean, two balls get collided with each other. We heard the sound, we saw the light, and they get heated. Then we can call it as the inelastic collision. The simple answer is what? Only momentum is conserved, not the kinetic energy. Okay, students. Here, if you watch it carefully, all the things are happening under the influence of law of conservation of linear momentum only. We'll learn that. What is the law of conservation of linear momentum? Okay, if no external force acts on a system, the sum of the initial momentum must be equal to the sum of the final momentum. Basing on this statement, we are going to derive the expressions for head-on elastic collision. Here, what is head-on? Okay, students, what is the head-on collision? Say this. These two bodies are moving over a smooth surface. Just imagine. Let it has a velocity of u1 and got a mass of m1, and it has a mass of m2 and moving with a velocity of u2. Let's say u1 is greater than u2. Obviously, the first body goes and it hits the second body. Temporarily, the second body will lost its shape. Then after it come back to original state. Right now we discussed about that only. Okay. Then see, it is the line of action of the force. Okay. After the collision, they move along the same line. We call it as the head-on collision. Okay, students. It is the head-on collision. And watch now. Here, a body is moving. It's a body. Okay. It has a velocity of u1 and got a mass of m1. And see, is the second body, okay, which is moving with a velocity of u2 and it has a mass of m2. Okay, here also u1 is greater than u2, as like here u1 is greater than u2. This body just brushes the edge of this body. Because of that, they get deflected from each other. That means the paths have been changed. You can see this kind of condition when you are playing the carom board. Okay, when you hit a coin with the bigger one, striker we call, then what happens? Their direction will change. Then what did happen? Actually, they are moving in this way. They stick together. Okay. Okay, students. After this, what did happen? They changed their paths. Okay, students. If they start moving, they deviated from their paths and they start moving, making certain angles from each other. Okay, students. Then it is known as the oblique collision. I think you understood. What is the head-on collision? It is the head-on collision. And it is the oblique collision. If they get deviated from their path. After the collision, we call it as the oblique collision. They move along the same line. We call it as the head-on collision. Okay students, now we are going to learn about one-dimensional elastic collision, or simply we call it as head-on elastic collision. Okay students, now we talk about the one-dimensional elastic collision, or simply we call what head-on collision. Okay students, means what? It is one-dimensional. Students, we know that what is the law of conservation of linear momentum. Right now we discussed about that. If no external force acts on a system, the sum of the initial momentum of the bodies or the system is equal to the sum of the final momentums. By using this law, we are going to derive the expressions for the final velocities of the bodies, and also it leads to another concept which is known as coefficient of restitution. It leads to another concept. It's a very important concept, okay, for JEE preparation and as well as the NEET. And my suggestion is, watch the video till the end to understand the topic in right way. Okay students, let's say it is a ball or a sphere. Okay students, it has a mass of m1 and it is moving with a velocity of u1 students. It is kept on a smooth surface, and we have one more ball. It has a mass of m2 and it is moving with a velocity of u2. Till now we are thinking that we are talking about the collision could happen if u1 is greater than u2. Okay students, this comes and it collided with this. They move together as a single one for a fraction of the time, then they get separated. Okay students, they collided with each other for a fraction of time, then after they get separated and they got the velocities. Is the first body v1 and it is the second one has a velocity of v2. Okay, and I told you, according to the law of conservation of linear momentum, the sum of the initial momentum of the body must be equal to sum of the final momentum. Here the momentum of this body, it is m1 u1, and see, it is m2 u2. Okay students, might be equal to, or it has the momentum of m1 v1. Its velocity has changed from u1 to v1, and the similar thing is happening. It is m2 v2. According to the statement, they must be equal. Sum of the initial momentum must be equal to sum of the final momentum. Then we can write it as m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay students, we are bringing the similar masses at one side. then it can be rewritten as what? M1 U1 minus M1 V1 is equal to what we have? M2 V2 minus M2 U2. In other words, we can write it as M1 of U1 minus V1 is equal to M2 of V2 minus U2. Okay, students. Let's take this as the equation 1. It is according to law of conservation of linear momentum. Linear means we are along the straight line. In the same way, while talking about the collisions, we took the reference of the two physical quantity, students. One is the momentum and second is the kinetic energy. We use the concept of the momentum here and we got a relation as this one. And the kinetic energy also has to be conserved. So we are taking the law of conservation of kinetic energy. It goes similar to this. The sum of the initial kinetic energy must be equal to the sum of the final kinetic energy. Means what? It has the kinetic energy, this one, half M1 U1 square sum plus half M2 U2 square is equal to final kinetic energies, half M1 V1 square plus half M2 V2 square. Okay, students, we are doing the same. We are cancelling half. And what you get? M1 U1 square plus M2 U2 square is equal to M1 V1 square plus M2 V2 square. We are doing the same thing what we did before, bringing the similar terms at one side. That is M1, okay, U1 square minus M1 V1 square is equal to M2 V2 square minus M2 U2 square. Or in other words, M1 of U1 square minus V1 square is equal to M2 of V2 square minus U2 square. Or it can also be written as M1 of U plus V multiplied with the U minus V. Okay, it is in the form of A squared minus B squared must be equal to M2 of, okay, V2. Okay, students. Say it as the equation 2, students. Okay. Next, what we are doing? Dividing two by 1. Okay, students. Second equation we have M1 of, okay, U1 plus V1 into U1 minus V1 is equal to M2 of, okay, I am taking some liberties. What I have? V2 plus U2 into V2 minus U2 divided by, okay, here this equation, M1 of U1 minus V1 upon M2 of, okay, students, V2 minus u2. Okay, students? Here m2 get cancels, m1, and this term get cancels with this, and it is. And finally, we have u1 plus v1 is equal to v2 plus u2. Okay, students? From this we can write a relation. What is this? u1 minus u2 v2 minus v1. Okay, this concept leads to is u2, students. Another concept known as the quotient of restitution, students. If you watch it keenly, you will observe it is the velocity of separation before the collision between the two bodies. See, here, before that, these are moving. Velocity of separation, and it is velocity of separation after the collision. Okay, or simply we can write relative velocity before the collision is equal to relative velocity after the collision. I hope you understood the relation between the two. And if you watch it carefully, we have the equation here. It is the major equation what we have to write. From this equation we can write final velocity v1 is equal to v2 plus u2 minus u1. Similarly, you can write v2 is equal to u1 plus v1 v2 minus u2. Okay, these two equations are very important in head-on elastic collision, students. Okay, students, I hope you understood this concept. Okay, it is the simple work of law of conservation of linear momentum. We use the two concepts which are involved in collision. One is the momentum and second is the kinetic energy. By using those relations, we got the equations for final velocities. v1 is equal to v2 plus u2 minus u1. v2 is equal to u1 plus v1 minus u2. Okay, then after we apply these values in the first relation, this one, to find out the velocity in terms of masses. Let's do it. Okay, students, in head-on collision, we derive the equation for the final velocities as v1 is equal to v2 plus u2 minus u1, and as well as v2 is equal to u1 plus v1 minus u2. And we have to find out the velocities in terms of masses, students. Okay, and you know that according to the law of conservation of linear momentum, we have a relation m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay, sum of the initial momenta is equal to the sum of the final momenta. If you bring the similar terms, what you get? m1 u1 minus m1 v1. Already we did this. m2 v2 minus m2 u2, or m1 of u1 minus v1 is equal to m2 of v2 minus u2. Okay, students, this is the equation what we have to use to get the final velocities. Okay, let's use that equation. Okay, students, and what we have, see this, m1 of u1 minus v1 is equal to m2 of v2 minus u2. Because of insufficient space, I am writing them and wiping off once and what's that? A lot of times. See this, if you watch this equation carefully, here these are the masses and as well as the velocities. I am putting the value of v1 in one of the equations. Let's see what we get. So this m1 u1 minus v1, what we had, v1 is equal to here v2 plus u2 minus u1. Okay students, okay, is equal to m2 of v2 minus u2. We are simplifying this equation, students. Then it could be written as m1 of u1 minus v2 minus u2 is v2, students. I have to write some sharp. Okay, minus of minus plus u1 is equal to m2 of v2 minus u2, or it can be written as m1 u1 minus m1 v2, okay, minus m1 u2 plus m1 u1 is equal to m2 v2 minus m2 u2, students. Here we are adding these two. What we get? 2m1 u1. Okay, I am bringing u2 terms at one side. Okay, plus m2 u2 this term. Okay, and I am already we have the term minus m1 u2 this one. I am taking it out. That is m2 v2 plus m1 v2. Okay students, then it can be written as 2m1 u1 plus u2 is common here, u2 of m2 minus m1, okay students, is equal to v2 of m1 plus m2. Okay, then it can be written as v2 final velocity is equal to 2m1 u1 by m1 plus m2 plus u2 of m2 minus m1 by m1 plus m2. It is the desired relation, students, for the final velocity in terms of mass. Let's do the second thing. We are doing the same thing here. Okay students, we got the final velocity. I am freezing it here. That is v2 is equal to 2m1 u1 by m1 plus m2 plus u2 of m2 minus m1 by m1 plus m2. Okay students, let's do same with the second. Okay students, now we are substituting v2 in the above relation. Let's see what we get. It is m1 of u1 minus v1 is equal to m2 of v2 can be written as u1 plus v1 minus u2 Okay, students, minus u2, it is m2 of u1 plus v1 minus u2 minus u2, can also be written as m2 u1 plus m2 v1 minus m2 u2 minus m2 u2, and it equal to m1 u1 minus m1 v1. Okay, students, it can be written as m1 u1. I'm writing the similar terms at one side. I'm bringing this here, m2 u1. Okay, students, okay, is equal to m1 v1, I'm bringing it here, plus m2 v1 minus 2m2 u2. It can also be written as m1 minus m2 of u1. I'm bringing this here. It is 2m2 u2 is equal to v1 of m1 plus m2. Okay, students, then v1 can be had as, okay, m1 minus m2 by m1 plus m2 of u1 plus 2m2 u2 by m1 plus m2. Okay, students, okay, it is the value of the v1. v1 we can write it as 2m2 u2 by m1 plus m2 plus u1 of m2 minus m1 by m1 plus m2. These are the equations for the final velocity of the particle, students, in case of head-on elastic collision, or we call it as the one-dimensional elastic collision. Students, if you like my videos, please press the bell icon and subscribe my channel.